Historically, we've developed lens tints primarily contrasting one color to another. We have a compromise there. As we've developed Prizm, one of the primary drivers is better understanding what we want to see in the environment and minimizing the compromises we make.
The path started with gaining a theoretical understanding of how the eye works. There's some unique features in the way your brain and your eyes are working. Those unique features are what enable us to play with tailoring light to increase contrast. In Prizm, the practical followed the theory. The theory was developed, and then we found the tools we needed to build what we had envisioned on paper.
Prizm technology is something we've been working on for 15 years. The new factors for us are better understanding the environment, which we've brought in the hyperspectral camera.
They would go into these environments and they would point it at these certain conditions and measure the entire spectrum. And then they'd do it over and over and over again and then bring it back to the lab, and we'd analyze this data and look at it, and we would find these patterns in these conditions. And we were like, okay, we're seeing the same spectral peaks in these places, and we know that we can filter these spectral peaks specifically.
It was just a step of creating the ingredients in order to copy what was on the computer into a real lens, and that's what started it.
The other tools are the actual dyes or absorbers we put into the lens.
The big win for us was to be able to find a dye that had these really narrow absorption peaks that were really similar to the transmission peaks we were seeing in nature in these environments. The old dyes used to be this big bell curve, and you would absorb everything underneath this bell curve. Now we had these small peaks that we could build in the environment, and everything in between there would still come to you and be let in. And now we had this lens that worked over a greater amount of environments.
So when you can take a picture and really understand how color is made in that image, then you can design a lens around those real colors that you actually have data. Gaining that understanding of how it worked enabled us to tailor these lenses to every light environment that our athletes are working in.
Through that interaction with the athlete and understanding what's important for them to see, once we understand the environment, we'll go in and we'll turn the knob and we'll accentuate their object of desire.
We've done a bunch of color science and looking at the biology of the eye, and found that there's two specific colors where your eye is very sensitive to detail. So there's a very specific blue and a very specific orange. So in Prizm Snow, we're going in and adapting it and boosting those colors and filtering the other colors out. When we first tried it with Lindsay Vaughn, one of the feedback that we got was that she didn't have to close her eyes when she goes around the corner, which we didn't understand at first. She was starting out in the trees in kind of a lower light condition. So when she came around a tree, suddenly you have bright, sunny light in your eyes. So you have to kind of close your eyes and let your eyes adapt. But with Prizm, there's not that big of a change in total light transmission. It's still blocking most of that light, so your eyes don't have to adjust nearly as much.
In the case of snow, think about good light and bad light. Good light is what I would call the colors that your eye is very sensitive to. Bad light is a color that maybe washes out your color vision. We can let a huge amount of the good light through, and we can take away almost all of the bad light. We've come to understand what those colors are, and we can manage them very well now.